Good morning and good afternoon to everyone on the call. Welcome to the Siemens and Maya HTT webinar that's focused on manufacturing and practical AI use in manufacturing. Today we'll be discussing how Siemens and Maya are utilizing artificial intelligence to revolutionize the manufacturing industry. So from predictive maintenance to intelligent automation, AI has the potential to increase efficiency, reduce costs, improve product quality, and that's what we'll be discussing today. So you'll learn about the different types of AI and their specific use cases in manufacturing, like computer vision, machine learning, and language processing. You'll also see how Siemens and Maya are implementing these solutions to improve our clients' performance. And we'll also showcase real-world examples of how companies have successfully implemented Maya HTT AI solutions in the manufacturing process. But before jumping into the content, I should introduce myself. So my name is Cord Recchi, and I'm a business developer for digitalization at Siemens. And although I'm not a data scientist by practice, I do find artificial intelligence to be extremely interesting and exciting. So I can't wait to hear what my partner Remy is going to share with us today, and I'll pass it to him for his introduction.
Thank you, Gorv. Yes, Remy Duquette. I'm the Vice President of Industrial AI at Maya HTT, and I look forward to introducing you to practical and successful adoption of AI in industrial manufacturing operations today. So it will be a lot of fun, Gorv, I'm sure.
Perfect. Thank you, Remy. Now, most of the webinar is going to focus on the practical application of AI in manufacturing by presenting use cases and reference stories from customers, talking about how AI helped them solve their challenges. But before we get to a trained AI application solution, we need to establish the means to get clean data, this data pipeline, to which we can then apply machine learning algorithms, machine learning techniques. So at Siemens, we've invested many resources over the past few years to help customers establish this data pipeline and make use of operational data. As you can see from the diagram, Siemens has solutions from the field level to the edge level to the cloud level, solutions that make it easy to connect, capture, and bring value to your business by way of data. What's been of utmost importance is building solutions that are open, easy to implement, flexible, so you get exactly what you want, and scalable to derive value across your enterprise. Of course, the only way we can keep progressing is by partnering, because no one team or party can do it all. And that's why Siemens has been a partner of Maya for many years. Maya is akin to a system integrator, but for IoT applications. They provide the service to bring data together from different teams, different systems, different platforms, and they create these AI-powered solutions, some of which you'll see very shortly. So, Remy, with that being said, I'll pass the mic to you to kind of guide the ship from here. So, thank you.
Thank you, Gorv. A great introduction. And yes, this stack is really what we leverage to deploy those amazing AI models and machine learning models. So it's very important to understand the stack and where we all play. So maybe just an introduction to Maya HTT. We've been in business for more than 40 years. We are #1 in terms of Siemens digital industry software partner worldwide in 2022 and North America in 2021. So we definitely pride ourselves to develop a great relationship and partnership with Siemens and leverage and integrate their systems so that your use case in the industrial manufacturing shop floor things go well. Of course, we do more than just industrial data engineering and applied and AI and machine learning. We develop also integrations for PLM, product lifecycle management, simulation, engineering and manufacturing simulation, and operations type of use cases. So you can see we are involved in anything that relates to physics. Our physics understanding and our technical staff is really key in the success of the stories that you'll see today. And you'll see our staff is shown here. 75% of our staff are scientists and engineers, so very, very technical and technically very savvy people at Maya. From an industrial IoT and AI machine learning components, our pedigree or track record is quite significant at this stage, especially in manufacturing industrial applications. So I think that's a right place to start, so you understand where we come from and where these use cases and successful adoption came from. So we've deployed 4.5 million IoT sensors. So anything from small data to big data is something we can handle. It encompasses about 150 clients and success stories and different industrial applications. So today you'll see a subset of some of those, but for sure, if you have a unique case, don't hesitate to reach out. We, with the Siemens Toolkit, we also can integrate to other third-party kind of systems in any industrial environment. There's always an eclectic mix of different equipment and communication protocols and things and in-house tools that have been developed over time for various reasons. And we can leverage all these sources of data, whether it's with an on-premise kind of deployment or an edge device deployment or a cloud or hybrid mix of all the above. So depending on your implementation stack, what you have today in your environment, we will use that and make it shine. And our expertise, 100% focus on industrial manufacturing and engineering. So anything physics-based that we need to understand the data and the throughput of your manufacturing is where we operate. If we look at the use cases, and we'll see very specific examples in different manufacturing and operations today that I will be specifically going into a deeper dive. But in general, there are really 8 areas of our digital transformation where our client use cases align well with leveraging data today. One is asset condition monitoring. So of course, the asset health of any operations, whether it's in the manufacturing shop floor or in industrial operations or fleet of different components, ships and vessels or trucks or trains, all of these kinds of assets or pumps and more oil and gas type of things. So you need to track and monitor what's happening in the field. So this is really the key starting point of many clients. Then you go into more sophisticated machine learning and digital transformation, where you can leverage predictive and preventive maintenance, increase productivity or increase OEE, overall equipment effectiveness, or increased product quality, or different use cases where you see value fairly quickly from a machine learning and new technology deployment in your environment. Then on the right-hand side, on the monitoring utilities and energy consumption, that has risen clearly due to inflation and other macro kind of effects, where these components now are of much higher value and come at a premium. So clearly energy consumption is a big, whether it's on the cooling or heating side or just the energy production side, we have very nice use cases there. Then on the fleet management, when you have multiple hundreds of thousands or tens of thousands of assets being deployed and need to be optimized as a system, is really where we can also improve your efficiency. And then the real-time tracking and industrial machine learning are segments of this. The industrial machine learning is really meant to augment shop floor workers. So when we look at a human in the loop, we leverage his capabilities and augment the human being in the loop to make him or her more effective in the tasks that are at hand. So really, our offering is in 4 buckets: the Industry 4.0 audit or alignment kind of consulting, where we put a roadmap and we look at the backlog of business use cases and pain points that you have. So this is where we sit down with you and see what's priority in your deployment and digital transformation, and then we go and create a backlog in an agile fashion, deliver on that backlog of items. And this is where the sensor fusion, data engineering, industrial edge components come into play, and then later on the dashboarding, advanced analytics, low-code, no-code applications running on it, and then finally the machine learning and AI, which is where everyone wants to go, but typically these are really the segments of services that you'd need and help that you'd need. When we talk about data, it comes at a premium in different cases, but you look at video as a sensor, right? So video and image are really essentially a different type of data that you can ingest in different ways. And thanks to the new deep learning techniques that have been evolved over the last decade, the machine vision is even better in some cases than human beings, given thermal imaging cameras can see the thermography of what's happening in the field, where a human can't really see if there's a hot spot within an equipment, or if there's a little breaker that's starting to act up and heat up. So these are kind of additional bonus of capabilities from a video as a sensor that we can add on top of your traditional telemetry that you're collecting for your SCADA systems and other manufacturing equipment. In a similar fashion, if you've walked on the shop floor, you've probably heard older folks on the shop floor saying, "Oh, I hear this weird sound. There's probably something weird going wrong with this machine." Well, guess what? With an AI model, we can depict what is really happening, the frequency shift, and transfer the acoustic time series into frequency domain, and then in real time understand the shift of those frequencies over time and understand what this means. It means, well, there's a belt that's going a little bit sideways, or there's something going wrong, or the bearings are not oiled enough, and they start making sounds, and they lead to failure. So abnormal machine noise is something that we can learn from, and that, by the way, gives a very high return, because you can depict those problems very early. So it's way before the telemetry start to act up or vibration starts to be audible. These other acoustic signals come into play and can be fairly early signs of failure. So that's an additional bonus of using audio as a sensor. As I said before, and we'll focus on a few detailed deep dive examples today, Maya, as a company, we focus on understanding the physics behind things and not just look at data for data's sake. We look at the physics behind what's happening from an engineering, manufacturing, operation. That's really where you'll see the use cases that I will be presenting that were adopted in manufacturing 24/7 environment. Makes sense because it's related to something that is physically meaningful, that we understood, that perhaps no one else really fully comprehended. So this is what we have. Now, when we sit with clients, often they look at a huge map of different data components, and yes, data is gold, but it has limited value if it's not accessible and organized. So in the maturity of your organization, you have to see and be honest with yourself as to where you're at in that path. And we can help you at different stages to get to machine learning and AI successfully. But if you're looking at this right now and you have all these data silos in place, the first step would be to organize your data and make sense of it. And when we do that, we have this digital transformation service that we offer to sit down with you and audit what you have. And the first thing we do is essentially look at, what are the pain points in your organization? What are your business challenges? And then from those business challenges, we align with, do you have the data? Do you have the sensors? Are there any gaps? And then we put a backlog of different changes and different things that we need to put in place, and slowly get you all the way, from the data acquisition to the contextualization, to all the way to the control and AI-based kind of machine learning predictive stage. But you have to think of it as 3 steps, and depending on where you are, we will be able to accompany you and help you across that digital transformation journey. So, first level set, to make this a little bit more interactive, we have lots of people on the call. So, we're talking a lot about AI in the industrial environment. But what really are we looking at? So I'll first put a polling question in. So you'll see as I poll here, okay, what best describes your AI maturity? I will launch the poll. So right now, you have a poll open. I will leave you a few, a minute, maybe a minute to answer it. answer your best you can. Are you not thinking of AI yet? You've started planning for your first AI proof of concept. You've ran a few, proof of concept or proof of value, as people put them now. Or you have a few algorithms in production already, and you've started to get the benefits from it. Or you have a very well orchestrated MLOps and culture of AI first. That's relatively rare these days in an industrial environment, but there are a few that will probably be at that level. So if you can answer in the most honest way as to where you think your organization is at, that would be great. And I will stop in a few seconds to show you the results of the poll. And that will help me also in the next few slides to tailor the message and the information based on where you're at.
And Remy, just wanted to quickly chime in just as the answers are coming in.
Yep.
There's also a box, there's a question box also in this little panel. So throughout the presentation, if you have a question that you need answered, please type it in there. We do have a Q&A time slot at the end of the presentation, but I just wanted to mention that as we go through the content.
Excellent and good reminder. So let me share the results of the poll. So as you can see, a lot of you are at the beginning. You're questioning yourselves as to, what are the first steps, and hopefully today you'll see, the progression and the steps that you can take to put in place, from the industrial edge all the way to the data gathering contextualization, and then all the way up to using machine learning and adopt machine learning in a real way. 30% of you have started with first proof of concept or proof of value, minimum viable projects that are going on. So that's great. So a third of the audience. 17%, that's actually good, that ran already those, but didn't move into production yet. So we'll maybe understand later the tips and tricks as to how to go from a proof of value or a minimum viable project into operations, and how you build the architecture behind it is important. 8%, so 1 out of 10 roughly, is have a few AI algorithms running in production. That's great to see. And 4%, are well orchestrated. So very understandable that at this stage, at least in manufacturing industrial operations, that is where you're at. So that was a first kind of pit stop for polling time, so that I can get some feedback from you. As you see, AI has gone through an evolution or a revolution to some extent. And if you look at it, back in 2016, no one was talking about AI, right? So we're talking, just a couple of years ago, it was not amongst the first 100 search terms in Gartner, right, at all. So if you look at a year later, in May 2017, all of a sudden it jumped from not even appearing to the top 100 to number 7. Something happened between 2016 and 2017. And today, if I ask you, have you heard of ChatGPT? Probably 99% of you have heard of it, and maybe a bunch of you have actually tried it. And there's even a full book that was published by a data scientist, a person that essentially wrote the book in 4 days with ChatGPT. I don't recommend that at this stage, but in any case, you can see that things have evolved a lot, and we're going to apply it now and show you some really interesting evolution into the industrial environment. But there are really 3 things that are fueling it. One is the compute power. If you haven't heard of TPUs, tensor power units, and GPUs, and you've probably heard of those. So the rise of GPUs and TPUs over the last decade, or a little bit more, has really fueled the training of AI. So now we can leverage the data and train on really big data and get useful machine learning out of it. So this is really one of the key elements that fuel the rise of AI. Then the data quantity and access is probably more important, because industrial environment in manufacturing environment, we've been using data for 50 plus years. But whether it's in control or any other kind of SCADA systems or other systems that we've been using to operate, but we may or may not have stored that data, or if we stored it, it might have been locally in various siloed databases, or sometimes in real-time historian database and sometimes not. So the access is really what changed significantly in the last decade or so, where now we can move the data in centralized places. It could be on-premise, on edge, or in the cloud, but it can happen and be centralized. So that's an important key factor as well. And finally, for the machine learning purely and AI components, there are frameworks that have been developed by the big companies, and they've made it open source. So it's open tools that all of us can leverage. So that combination of three factors is what is fueling the revolution, really. If you look at AI versus human in terms of image processing, so back in 2010, you would have look at AI, and that's why it was not so hyped at the time, or not used at the time. You can see the error rate of the best-in-class error rate at looking at an image. And think of when they're asking you if you're a real human being, is it a leopard or a tiger or whatever, you're not sure. So that's where the human error rate is at about 5%. Or is it a bicycle or a bridge, or are there really lights, or do you pick all the lights, or just where the lights are shown? Anyway, the 5% error rate is the human basic error rate in image processing and detection of objects within an image. The AI component, the deep learning component, mostly through what we call convolutional neural networks, essentially look at these images, and between 2015 and 2016 is when that AI architecture and deep learning model became better than human being. And by the way, it can process 14 million images very quickly. So clearly you can see a shift, and that's at the same time where in that timeline that human beings and at Gartner, when we went online and searched for different keywords, AI all of a sudden appeared. Well, so clearly there were a lot of things that were happening during that period. In the same period, and I'm not talking about Deep Blue beating Kasparov in 97, that we knew that, human versus machine, check, okay, that was done. I'm talking about, learning from data, right, versus programmed by human beings. So chess programs, if you know, the Stockfish is one of the nice program that people use to train themselves to become good chess players. But it's programmed by human beings, right? Based on rules and number of layers of things that you're going to look at, and how deep you go in the mix, versus learning from self-playing against yourself millions and millions of times to figure out how to beat yourself, right? And eventually how to beat any player. So that's what happened there. In 4 hours of self-play mode, the AlphaZero essentially destroyed a 100-game match, the Stockfish, and it just learned by self-play. That's a new paradigm, right? Learning by machine instead of programmed by humans. If we look at it from a telemetry standpoint, right? DeepMind put a nice paper out where they essentially reduced the power usage or the cooling use, the power used for cooling in their data center by 40%, which turned into a 15% total energy efficiency gain. And you can see the drastic, right, control and the better control that machine learning has versus no machine learning in the control aspect. If you look at it from an oil and gas perspective, an hydrotreater system, you can see here that using reinforcement learning, it can improve significantly beyond PID controllers, while you can still use PID controllers as a fail-safe mode to make sure that we've relied on those PID controllers for ages, so we can use them now as the safeguard in case something goes wrong. At least if you default back to a PID controller loop, that you're going to go back on your footing, and you're going to be okay. So because it's been very reliable and robust. But while it's reliable and robust, you can see on the left-hand side of the signals, it's very inefficient. It's always trying to catch up on the signal, right? That's how PID controller work. And that's fine, it's robust, but it's inefficient. And that noise, right, means it actually abuses the parts in your equipment. And that turns into, of course, a asset useful life that can be reduced. If you apply AI controller techniques, you see how smooth the control signals are, right? So you're no longer abusing the parts inside your system. And so that is where the useful life is elongated significantly. So that's, interesting benefits of how AI can be applied. So now to make it a bit more dynamic, we'll go to a second little poll. So in this one, we'll see what are the use cases, AI use cases, or where you want to apply AI that are of more interest to you. So in this case, is it increasing? You can check all that applies. It can be multiple choice in this case. Increasing quality of the products, increasing the manufacturing productivity or E-type of system or the line effectiveness, reducing downtime, so using predictive maintenance applications, improve or further optimize PID control loop, right? Reinforcement learning, a little bit what I showed, or create new after-sales data-driven value-add services. So once you've looked at the data of the usage perhaps of your systems or products when they go out, well, maybe you can provide value-add services using machine learning. So those are all interesting components. So again, I'll reiterate, if you have questions, don't hesitate to also put these questions or in either the question box or the chat box in the system, and Gorf will go through them at the end with me. I'll just give you 2-3 more seconds here. And we will close this here and let's share the result. So quite interesting, and I was sort of expecting that, yeah, quality, product quality and productivity would be very high, and in this case, they're exactly the same at 67%. This is really interesting, and actually, most of our clients will start with quality metrics or productivity metrics that they are measuring today. So as a metric, right, anything that you measure today is potentially a good starting point for an AI project, because if you are measuring it, you're going to see the impact of AI very quickly, because you're going to see if it improves your metrics or not, right? So these are really good starting point or places to look for these types of AI applications in manufacturing. Reducing downtime is the next on the list, and it's kind of in order, but it makes sense as well, because a lot of people will look at predictive maintenance. Now, in terms of effort, typically predictive maintenance will be a bigger effort from an AI modeling standpoint. So I'm glad it's a little bit lower down but it's very close actually to the productivity and quality in this particular case. But in any case, interesting. And then improve the PID control is probably something new that you may or may not have thought about. So hopefully it will generate some new ideas of AI use cases that you can apply safely and successfully today. And the last one, 27%, that's actually huge, because in the past, this was a bit like maybe 10% or so. So it's definitely grown significantly over the last year, which I'm very happy, because this is where you gain most by applying AI at the end of the day, is on augmenting, creating new streams of revenues for your company. So that's clearly, of course, typically also aligned with a bigger effort, but there is a bigger return on this side. So 27% is amazing. Excellent. So that will help me focus the next few components. So as you see, just to reiterate, right, you want to go to the top and apply AI, fine, and that's great, right? We need to get there because the tech does have huge benefits for your organization, and there are real benefits, and we'll see some very specific case right now But as you go through it, don't try and boil the ocean and go to control first and apply AI first in predictive mode or control mode. Start with collecting the right data, visualize it, contextualize it, and then understand what's happening in your environment. And then you can then build best-in-class prediction tools and control tool for your environment. But again, if you skip any of these steps, I make the analogy. This is Mount Logan, by the way. It's the number 6 biggest mountain in the world. It's a Canadian mountain. If you skip any of these, you may slide down and fall. And so you want to follow the right path to success. And this is the right path to success, to not skip these main steps. So we've looked at a lot of these use cases. So some that are revenue generator kind of AI benefits, others are cost reductions, other are risk reductions. So when you look at building a roadmap, right, for these use cases, what you want to do is list all your pain points and then rank them. And Maya has created a nice matrix where we can help you with ranking these business value and roadmap creation and create a backlog for yourself. And typically what you want to try and establish is a number one, a time to implement that's very low, that has the highest business value. And you typically start there because it's going to help you with the change management and the infrastructure that you need to put in place for these projects to be successful. So starting with kind of a map like this that you see here, and organizing yourself and creating a backlog, and then go and deploy technology and take care of change management as you go through the first one and the second one and third one. And then you increase the value that you get from an AI. From each of these specific project, then you want to dive into one layer more of detail. So we have a nice get ready project Canva that we follow religiously, because it's very good to align everybody, understand what we're going to do, what the output is, the infrastructure needed, is there any gap right before you start. So this is a nice Canva to leverage, and that's been proven to be quite successful. Now, let's look at very specific tangible examples from our clients. One is in the continuous process manufacturing, so pulp and paper, in this case, customer. So their use case, so the business use case, right? What did they want to do with AI and machine learning? So they wanted to increase the product quality. They had 20 quality parameters and they needed to increase it, and they needed to reduce the machine startup waste. So those are the two key elements, right? The low-hanging fruit, so to speak, that they established was important for them to look at. And then we looked at their infrastructure. They had about 600 or so inputs, sensors that were giving data, and then align that data to match the output of the quality. There was a lab with more details on these 20 parameters and some less, with scanners that are more real time. So there's all of this mechanics that was put in place. And if you remember, during COVID, at the beginning of COVID, we all rushed out to somehow buy toilet paper. I'm not sure why we did that, but anyway, the point is the shop floor workers, right? There was clearly a new workers that were brought in to help, and they didn't have the experience and expertise of the older shop floor workers, and so the variability here became very difficult to handle on the quality side. So that's where machine learning was helping to augment these younger workers with less experience and give them tips and tricks on, and in the oops moments, or the moments where you make a mistake, they can be corrected by the system, giving them the next step to do, increase the speed of the conveyor belt, or reduce the temperature in the drying section, or whatever it might be, infuse more resin, or pulp, or whatever at the beginning. So depending on what the case was, they were given tips and tricks to get to a better place and in the best and fastest way possible. So this is really an interesting case. Now, a completely different use case is in the discrete manufacturing. So in their case, lithium batteries for electric cars, right? They, at the end of the production line, they had 10 stages of manufacturing, and after all these 10 different stages of manufacturing with about 16,000 data points, if I recall properly, they had product rejection, as any quality control and quality variability that was pretty difficult to manage. So they wanted to improve that, and they wanted to reduce the cooling aspect in terms of the time of the last stage of manufacturing. So those two elements, we applied machine learning on one hand to reduce the variability and of both quality and the performance of the batteries at the end. And we also were able to help them reduce from the 24 hours to 14 hours of cooling time at the end of the production line to wait before they were able to ship. And again, that was thanks to some machine learning algorithms that understood the fact that we were not tracking just temperature over time, we were tracking the voltage and amperage as a function of temperature that changes over time. So this is a more complex from a physics understanding of the batteries and the chemical and the processes around it. We were able to produce an amazing set of deep neural networks with high accuracy. Now, some people think they have a lot of data, some people think they have not a lot of data. So in this particular case, the reason I mentioned it in the robotic composite smart manufacturing is because this client only produced about 400 of those domes that you see there per year. So it's not a huge, massive production, but they still had a lot of quality issues and a lot of manual rework. So they looked at us and say, okay, could you use the telemetry of the robot, maybe fuse it with image processing or something else so that we can see what's happening and pause the program in real time so that we don't build up issues that are very difficult to fix down the road. And lo and behold, by following the telemetry, we were able to establish when a fiber was twisted, or when there was too much resin or not enough resin, or there was too much tension or not enough tension in the fiber that was laid down. So all of these created defects locally that were easy to correct and on an ongoing basis, and did not build up over time with that composite part having maybe 40 to 60 different layers. So in this case, it was very interesting that by finding 29% of the defects caused purely using the telemetry and the imagery as inputs, we were able to save about 80% of their manual rework. So that's a huge improvement. And again, machine learning projects do not have to be complex, right? It can be in a very simple environment, like in contained environment like this one, where you take a few inputs and you augment it with machine vision or machine audio, and all of a sudden you can do wonderful things in AI space. On a completely different set of problems here, fleet digital transformations. So CSL, we presented with them multiple times in public, have these large cargo ship, 60 plus of these cargo ships going around the planet. And they're really mini factories. They're wonderful mini factories, floating factories that are moving dried goods around the planet. And because they're mini factories, they have not only all the vessels, systems, navigation, and the engine room and all the pumps and everything, but they also have conveyor belts and movable booms and anyway, all sorts of equipment that you would typically find in a manufacturing plant. And so we had to instrument them, and at the beginning they were, pen and paper and spreadsheets and a few data that they would collect and ship over to their central office to be able to kind of make some analytics after the fact. So we fully created an edge device, essentially a box that lives on each of the cargo ship, and then asynchronously when the satellite is in view, or when they get near to shore, they can asynchronously upload the data to the central server, and then all the analytics and the logistics and the optimization can happen, and the predictive maintenance and regulatory compliance as they're sailing can be tackled. So this is a very interesting, more in-depth digitalization project, and hopefully if you're managing a fleet of industrial components or assets, we can definitely help you get there, again, in a very systematic, step-by-step approach. A completely different use case still in industrial space. In this case, it was when we sat down, we figured out it was not on the manufacturing side and machining side that was a bottleneck. It was on the procurement, or sorry, in the costing side. So to essentially churn out quotes based on metallic parts, custom metallic parts that were submitted by their clients. Our client was, wanting to machine these metallic parts and provide a quote to their client. And of course, the accuracy of the quote is very important because that's how they derive their money, their margins. So we had to come up with a cost prediction for them, because the quoting process could take between a day to 5 days for the more complex parts. So 5 days to wait. Sometimes they even couldn't supply the quote in time for their end clients to consider them. So that was a big problem. So for them, increasing the speed of quoting was really paramount. So again, low-hanging fruit, right? You take a problem that you have and you apply machine learning in the right way. In this case, we took custom 3D CAD parts and features, geometric features, and turned these as inputs to a machine learning algorithm, and then leverage that to estimate the G-code structure of the machining components, and then the associated cost plus any other machine surface treatment or colors or whatever it is, painting or something else that would needed to be done. So these are all components that help, again, augment the human being in the loop to make them more efficient and more productive. Very interesting case on large scale data center for cooling optimization. You can see here, better forecasting of the cooling demand. So as if your data center is your business, right, you have a big problem to manage the cooling aspect, because cooling, if you put too much cooling, which is good for the IT equipment, it costs a lot, right? But if you don't supply enough cooling, then you're putting your IT equipment at risk. It can burn up, it can overheat. And so in this case, you need to reach the right balance, because either way, it's costing you a lot. So you need to really aim very, very precisely. So as you grow your data center business and the cooling demand, it needs to be adjusted. So here we helped with the reducing the cooling costs and reducing the hardware risk by better forecasting the cooling demand. So how do you envisage yourself getting AI ready? So I have a last poll here. That's an interesting question of, what's your preferred way to get started? Build your own data science team. A lot of people do that. That's great. We can provide you training or upskilling if needed. Or we can augment your own data science team with external people like us at Maya. Oops, right, wrong. Launching here. So I'll launch the poll while I'm talking. So you can just click one of the three options there. Either build your own data science team, augment your own data science team with external industrial specialists like us at Maya, or outsource entire projects to us. So that's kind of the three ways, and there are pitfalls in each, right? If you outsource completely the project to us, while it's great for us, sometimes we need to do transfer learning at the end and training at the end, because and that needs to be factored in to the project, because we see the value and the success, and clients being able to then continue and improve upon what we've delivered, right? If you want, we could be there for a long time, but that's fine. And some clients prefer that way. But in any case, you have to factor in this. So it's very interesting. It's very well understood, and I'll just give you a few more seconds to numbers are still fluctuating a little bit. Excellent. Yes, we have quite a few of you have voted now, so let me close and we'll share the results. So I think as expected, most of you prefer to augment your own team, data science team, with external people that can add value. And that's really smart because not only you get the best from us, but you also ensure continuity of your own team moving forward. So certainly 64%, I'm very happy to see that. 25% building your own team. Yeah, that's great. If you have industrial specialists and data science specialists in the same team, make sure you team up those two types of talent. That's what will make you successful. And the last 11% outsource entire project. Yeah, I'm glad to see it's it's 1 out of 10. So that's great. That means you probably have perhaps a smaller business and maybe you don't have internal kind of enough projects to justify a full data science team within your company. So those attempts here makes a lot of sense as well, and then we can help you maintain it over time if that's the case. So that's great for the poll. Thank you for answering. Actually, a lot of you, most of you answered, which is great. I'm glad we're having a dynamic conversation, even if it's a webinar today. So maybe a key lessons learned before we close out with the Q&A session that we've learned from our clients and their journeys. So hopefully these lessons can help you. The first one is perhaps one of the key ones. To be successful with an AI model, you need clean data, but not clean data in the sense of, don't copy a big historical data set and give it to a data scientist, and then they will clean the data offline with a million tricks. But then when you put back the AI model in production, it's never going to work because what the data scientist did offline has never been applied inline, right, in production. So you have to be careful about this. When we say assume your data is dirty, that's true. All data in this industrial manufacturing environments that I've looked at all look dirty, like the one on the right here, right? Maybe when you start and you have a perfectly clean slate and it's the first few weeks of production, everything goes right. Okay, maybe it's clean. But at some point, things starts happening, and the sensor gets moved a little bit, the vibrations get involved, and things go sideways, or the machine that's 5 meters away is all of a sudden unbalanced and creating vibration that is now affecting the sensors on the other machine. So things will happen, right? So what we see on the right-hand side is typical. So all you need to do is build good data pipelines, right, that take the raw data. You never get rid of the raw data. The raw data is always there and safeguarded. And then you build data pipelines, right, to take that raw data and supply it to either your dashboard or to your AI model, right, or machine learning model, so that it's easy for you to repeat and see, okay, if I can train the data by using these data pipelines between the raw data and my ML model, I put in production, I'm going to get the exact same result of accuracy, or close enough anyway, than what I've trained the model with. And so that's key in a successful adoption of AI in 24/7 operation. That's a key element to consider for sure. Now, why is industrial AI so different than any other AI models? Well, a couple of things, right? I said if you look at the pulp and paper example of 600 sensors, well, from the beginning when you put pulp to the time where you have the roll of paper, there's about 25-30 minutes lapse time, right? And you have 600 sensors across. So when you take a paper cut at the end, right, of your roll, well, that is actually correlated in time to 25 minutes ago for the first sensor, and then 22 minutes, 18 minutes, all the way to where you cut the paper. So really, you have to be careful on production lag time. It's complex and dynamic, right? If you change the the speed of the conveyor belt, well, it's going to change the lag time. Well, your AI model needs to know that, right? So all of these kinds of inputs and correlation of when you take the inputs and feed it to your ML model is important. So that's what we call also time warping. It's a little bit complex concept, but in any case, you get the point of, if I augment the speed of my conveyor belt, it's going to change my lag time. Asset failures and product quality results are typically not big data, so you may take samples for your quality across time. It's probably a random sample that you take, so you may not have big data on the quality result side. So that's maybe more difficult and unique in manufacturing environment. And sometimes sensors are cleaned up or maintenance of systems happen, and there's no record of it in your data, right? But the data does change. So assign a data custodian that will take care of marking the data properly and making sure that what is fed to the machine learning or dashboard is relevant to your operations. One thing to watch for is your subject matter experts can read the data in ways that are fantastic, but they might be biased in the sense of, if you're an English speaker, you can probably read the paragraph here. I couldn't believe that I could actually understand what I was reading. So you can see that you can use any first and last letter of a word and shuffle every other letter in between, and you'll be able, as an English speaker, to read this paragraph. But if I feed this to ChatGPT, I can guarantee you that that's garbage, right? They can't read that. So from that standpoint, it's very difficult to understand. But from an industrial standpoint, your shop floor workers, when they look at trends and data, right, they make decisions based on what they're seeing. But what they're seeing is what we're seeing here. It's a little bit garbage. So if you feed the same information to an AI model and expect that it will actually perform well, I think you can see that it's not going to happen. So there is biases in the data, in the way that you look at the data, that needs to be decoded for machine learning and AI models to work well. So something we've learned to avoid in industrial AI projects and machine manufacturing projects, but something you need to consider yourself. The best practice, I've said it a lot, involve people early, avoid sudden change, be agile in your transformation, take small steps, and this is where we'll get to, how do you get started? So the main thing here is expect that there's change management, expect that people will need to understand what's happening and understand they're going to be augmented by this technology and not replaced by this technology. All our projects thus far have made people more valuable. So actually the CFO wanted to hire more people because everybody is more efficient on the unit basis. So from a data standpoint, rolling out these AI projects in an agile way makes a lot of sense. So take small step, take one small business problem in your backlog, follow the metrics properly, and look at the data that's required to make it successful, integrate that minimum viable data set, and so on and so forth. So as you deploy these minimum viable projects, you'll get the hang of it, and it's fairly natural once you get started in an agile way. So hopefully you can give us a call if you need any help to deploy this in a systematic way and successful way. So hopefully you've learned today how to deploy properly, a few examples in different environments, manufacturing, discrete or continuous manufacturing, or fleet management and industrial operations. So hopefully that gives you some food for thought and good examples to be successful in your own journey. So with that, I will transfer back to Gaurav, who will lead us on the Q&A session.